Okay. Okay. So I think we technically have all the X, I think.
Yep.
Kind of.
Yep. We have the X, I think we have the Y also, because
Yeah,
what
Y is also there, yeah.
Exactly. So now all we have to do is just create the linear regression model. So just you can open a new tab, go to linear regression, find out what that is. So, okay, let's see what all we need. We are going to first create a linear regression class, and as I already said, some of these are pretty much default, like fit, intercept, normalize. We can just leave most of them at their default values, unless you really know what it is you're doing. So what we have to do is we have to now split our x's and our y's. So for example, we need to do a train test split.
Yeah.
So what we can do, I think you said it can take a data frame. If not data frame, you can just take it into you can just do a 2 NumPy array so that we have an x and a y.
No, they work directly.
Okay,
data frame. This is anyway an NumPy array, so it should work.
Okay, whichever. So all we have to do is we just take an x. We can just collect our x's as the columns that we want to designate as x's.
What?
You can continue. You have to anyway do this, right? So I'm going ahead of myself.
Okay. Then I think it's called the train test split is in where is it? Yeah, model selection. Okay. And so one thing we do you want to, okay, this is just a regression, so we will not be able to do much of so tools like cross validation and then confusion matrix and all. Do we have anything on that line for regression? We just plot it and see, right?
See, it's like this. Technically speaking, when you want to create a linear regression model, you want to know what are your variables that affect the output. So, to do so, the actual scientific way is to actually tweak this thing, correlation. To calculate the correlation between all the variables and the output, to know how strongly they are related. So, if a variable is not strongly correlated, then you can drop it. So, for example, you can do a correlation between, let's say, Snap CA and sales to know if these are really correlated. So you can just, I think you have to Google to know how to correlation the thing is.
Actually, this will be, we need correlation in a time series sense, right?
Well, not that much. We're just taking a correlation between two this thing, arrays of vectors, however you want to say it, right?
Yeah. That's true.
Because we have now completely messed up our time series. We have them all stacked one after the other.
Yes, true. Yes. I'm sorry. Yeah, that's true.
So
it's no more a time series.
It's a kind of time. Yeah, but it's like kind of it repeats itself. So it's like very different.
Yeah. Okay. So then, So correlation is in where is the correlation?
You can find out the correlation even through Seaborn, because Seaborn also has it, but
So it
this
is in
can,
NumPy.
yeah.
Okay, so it's here np.core coef. Okay, np.core.
Actually, do it in a separate one. You can execute that.
Sorry, yeah, sorry. Okay, and it will be something like, let's say, you want to do it between what?
No, you want to just check. Let's say any of them. Take Snap CA.
Snap CA and sales.
Yep. So, as you can see, it's pretty... no, that's the thing. See, the first, it's like this. The diagonal elements show how they are correlated with themselves, which is obviously 1. Yeah. But if you look, the correlation of the others is pretty poor. It's quite weak.
Yeah.
So now take something that you think might be good, like selling price with respect to sales. So you can just compare this, same thing. You can start a new command. Okay. So now you see the correlation is much stronger. So this is the idea behind, like, basically before you find out a linear regression model, you want to know if the inputs really affect the output. If you think that it doesn't, you skip it. So if something is that weak, you can just drop it. Like the other one, SnapC is very weak. So you can try, for example, weekday instead. Weekday should be somewhere in between, because selling price is pretty strongly correlated, that we know. So like, weekday coded or month or sign or something, right? So
it's quite bad.
It is still, but you wouldn't throw it out. At 6%, you wouldn't throw it out.
The thing is, this is actually foods. So foods, I think, will not be a weekday weekend correlation, would be not that much.
Yeah.
But Shiva, maybe there is a possibility that this is weekday is, I will have to check what exactly, because this is like, it's from 1, 2, 3, 4, 5, 6, 7, I think. So the value, would it matter or not? I don't know, because I'm not sure if it's a good idea to do a correlation between a categorical variable and a float.
Well, I would say I don't think there is really that much of a problem. See, it's like this. If it is categorical, it is still categorical with respect to integers, and the main thing is, see, it's like you can now do, for example, how do I say this? If you say, for example, month, right? Let's say you take month and take month sine or month cosine and see how they vary with respect to sales. So let's say do between month and sales and month sine or month cosine and sales. Now, for example, here you might see there is an effect of the cyclical thing. So if you do a covariation between month and sales, right? Alright. Now it's the same thing, but with month sine or month cosine. I think month cosine is better. So you see, it's much better. Though it's still quite weak, it's much better, because the idea is, because we did that cyclical conversion, it is now seeing some kind of a pattern.
Yeah. Do you think we should do that for weekdays as well?
I would say we could, but my guess is that
but it's not really relevant, because
exactly.
if we, I think,
because
it starts with, see, the only issue is that maybe we should change the coding. If I remember, the weekday starts on a Saturday. So for us, if you remember, you said that we can keep Friday, Saturday, Sunday as or together, right?
Yeah, okay.
So perhaps we should recode them.
Oh no, wait. Is weekday coded only 0 or 1?
No. Weekday coded is...
Can you just check what that is? I forgot what it is. Yeah, it is only one sale. So that is actually.
Okay. I see. Yeah. And we have already taken care of that. Okay, then.
Yeah.
Fine.
So then there's nothing more to do with that. So that's basically this. So then this what shows. So the difference between correlation between month and sales and month cosine and sales. So this. Yeah. So but this is the idea that before you do this, you would want to do some kind of correlation. So if you want, you can skip snap CA. That's one potential.
Yeah. No, but then the thing with snap CA, in my opinion, is that because it's a very small number in terms of very small in terms of the number of days where it's not. I think that's a very small. Let me just see how many. It's like not, is it?
Oh no! You want to do. In this case, you will have to do not equal to. I mean exclamation mark equal, not equal to, because I don't think it takes that in a query.
Oh.
And you have to cast it. Oh, you can do some also. Actually, count is better. Count is better.
I'm sorry?
You can do count to know how many of them.
Is it? No.
Oh. np.count? np.count should be.
Oh. NumPy has no attribute count.
Oh, I'm surprised.
Okay. But sum is fine, good enough.
Okay.
So, or I will say, let me see, equal to 1.
So basically, okay, summing it up, okay.
So, I'm just going to say, divided by length of this, I guess. Yeah, it's about 30% of the days are counted as snap CA. But yeah, so which means that that is not really leading to a big, at least in California. So for this current state, because California is a rich state, perhaps that nobody goes there, nobody cares. But anyway, so we can. You think we can drop this, right?
Yeah, that's the thing. If or we can do it once and then drop it and check it, do it again, whatever.
Yeah, let's keep it and see if that we'll do.
Yeah.
So we'll know clearly whether something is better or not.
Typically, if that is the case, the coefficient for that is usually so small that it's kind of not relevant at all. Usually, that's how it works out. So it's like it's wasted effort trying to fit that, but doesn't matter.
Yeah.
So we can continue.
Do you want to normalize selling price?
I don't think so. Why do you want to do that? Oh, okay.
Because compared to say month again, month we have managed it to keep it between -1 and 1. I think.
Yeah, because it's sine cosine, right? So yeah.
Yeah.
In terms of
I think selling price is quite arbitrary, and we might, because this is one reason why we see such a high correlation, because I would say it might even be that there is a negative correlation, but we don't see it because the high ones are leading to something. I don't know. So we do you think? Let's say I'm going to just do. I'm going to try. What is the way to quickly normalize it? I will just check. Normalize a pandas. Okay. So there is a pre-processing stuff.
I would personally say it's not really worth it, because in our case, where this really matters, at least normalization, is when you're trying to do a classification or something. If you're actually trying to do a prediction, then it might be worth just keeping it as it is.
Mm-hmm.
When you're trying to do a classification or a clustering, then it does make sense to sort of put it together, because clustering and classification, they use the concept of distance. Linear regression, on the other hand, finds a coefficient, so it's okay. Whereas if you're looking at...
Let's do it.
Yeah.
Let's try without it, and let's see how it goes.
Yeah.
And maybe we can try, as we suggest, we discussed, we will try with and without and all that later.
Yeah.
Okay, so so we have downloaded linear regression. So I'm just going to linreg. Okay, and or I'm going to see what all we can do.
Like I said, I think, I would just leave it as default, unless you know, like for example, if you know for some reason that you don't want to fit the y-intercept, then you put that as false or something like that.
Okay, perfect. And then what it has to do now, linreg has...
no, we never have to do this thing.
We have to first do this
split. Yeah, we have to do a split.
Train split. So x train, x test, y train.
Oh, you know about
y.
it. Do you already know this by heart? Actually, I would say always look it up, because it's like it's a particular.
I know. Just why I'm saying that is because we can now look it up.
Okay, good.
So we can just give, I think, So we need to now create x and y. Perhaps. Do you think that's a good idea? Because
that should be, yeah.
I think we should do that. Anyway, so x is equal to I'll first do this and then drop one of the columns.
Yep.
So x dot drop.
Actually, if you do drop on that, it returns a call. It returns a data frame, so you will get x on.
Okay. So I will do that. Then we will drop sales. Okay, so I'm just going to confirm. Yeah, looks fine. Yeah. Then y is equal to
x of sales, that's all. Oh no, whatever is of sales,
yeah. Okay, so this test train split now would be let's check y. Okay, it's a series. But anyway, so what all things we'll have to give test train split? You have to keep the arrays, train size. Yeah. So I'm just going to check quickly how do you give the arrays? X, Y, and then you give test size and then random state. So I'm going to say X, Y, train, no, sorry.
Test size, actually.
Yeah, test size. Oops. What is happening? Yeah, test size. Why is not coming? Oh, okay. I put this. It's not working. Okay. I'm just saying.
Auto completion. Okay.
Yeah, and then random state.
I think 0.3 is better. 0.2. 0.2 is okay, but 0.3. I don't think random state. Okay. Yeah, random state I usually don't use. Random state is when you want to like get the same result as somebody else. You want to start at a.
Yeah, I see. I'm just going to quickly check the order: x train, x test, y train, y test. Perfect. Good. Let's see if it works. Okay, got it. Solid shape. Yeah. Okay. We have fairly good amount of data here. So okay. So
now we can do our fit. That is on LinearRegression, on whatever that LinearReg.
Fit. We do this x and y, and sample weight is none, and what it returns an instance of self, which means you don't have to do anything.
Yeah. So just x train, y train.
X train, Oops. And then y frame. Okay. Now, what do we do?
.cof, I think.
Cof, yeah.
These are your coefficients.
Okay. Yeah.
So now what we can do is just check in LinearReg, but you might have something for calculating your y given a particular x. Then you can do that for x test. So if you do LinearReg dot, you will get something.
Yeah, it's called...
I forgot what it is. If you just do dot and see, fit, intercept, predict.
Yeah. Predict, you have to give the x. Okay.
X test.
X test.
And here you will have to assign it to something. So it will be like y predict. No, it will be y predict.
Y predict, yeah. And then now we plot.
Yeah, plot them. Right?
Yeah.
Actually, you will have to plot it with respect to integers because they are with respect to something. So, can you take the length of this y predict and check?
Yeah. So, yeah.
Or you can actually plot them two separately so that, but they will just appear on the same. So if you just plot, that's what.
Okay. We can just do it this way, and then let's say, oops, oh,
it's coming.
It's taking time. Yeah. It's going to take quite some time, is it? Yeah, because it's a lot of data. Maybe there's a problem. I don't know.
Can you scroll up? What exactly? How much? We have like 100,000 or millions?
It's 225,000. Yeah, it's there. I think it's to do with something to do with the. Most likely. Let me just check what x, y predict and x predict are. So this is what? This is an array, and y test. What is it? It's okay.
To this two numpy.
So I think I'll put an np.array of.
Yeah. Okay.
Yeah, I think this is what we should. Okay, let me just take this. np.array of y underscore test. Yeah. Okay, so we probably have to.
Just fix size, plt.fix size.
Yeah, fix it, yeah.
Now, plt.figure. No, you have to actually create the figure object and then, within that fix size. No. Inside that, parenthesis. Yeah. I don't know, 10 comma. That's a very big one, but okay, fine.
Okay, maybe.
You can also actually plot the error. That might be better actually, rather than this.
What?
You can plot the error.
Yeah. Let's do that. That makes sense.
You can just actually what you can. Okay, that is also fine. Yeah.
Okay.
So good news is it's centered around 0.
Yeah.
And if you plot, actually, again, we don't really have a way to know, but can you find out the mean price? The mean sales, can you, because we are predicting sales, right? Can you go to the sales in the sales column that we have above? So, in that data frame. And if you take sales and do mean.
np.mean?
Actually, on that there should be a mean. You can, this also is okay. But
yeah, it was there. Okay, now it's coming so slow, my God.
Yeah, actually you're running out of memory because it's like kind of complaining. So you see, this is the mean. So, well, in a way, it's not really that great news because the mean sales is 1.37 Now our error seems to be in the ratio of around 5, between 5 to 10. If you really look, most of the error.
Yeah. I will try a mean of this. I think it's a non-zero mean. It's a negative one.
Yeah.
But it's fairly good.
Actually, that's not bad. Yeah, that is not bad at all.
Yeah, because this is a linear one, and it has done a very good job of not going all over the place.
Yeah, sounds like it.
Yeah. Okay, so.
Yeah, well, this is a linear regression model.
Yeah, this is a linear regression model, and it seems to do something.
Yeah.
Okay, let me just. Okay, today is what, 25?
Yeah.
So let's stop here with this. Okay, looks good. We have completed somewhere, got somewhere.
Yeah.
Because the main challenge is usually the first part of getting the data and all that in place. So, okay. So I'll upload this.
Yeah, just concluding. Harish, anything to you? Anything you want to say?
I'm sorry? Yeah, Harish.
I have not understood about this correlation.
Well, basically, correlation is this. It just tells you how two variables are related to each other. So, for example, if there's one variable, which is, let's say, there's basically two types of correlation. There's positive correlation, which means if one variable increases, the other also increases in some kind of a proportionate manner. There's inverse correlation, which means if one increases, the other decreases. So that's negative correlation. And poor correlation is when there is no relation between. So if one is changing and the other is constant, then that means that there is nothing really in common between them. So what that means is if the two variables, go ahead.
Just to clarify, so the idea here is that, for instance, if there is weather is hot, people buy and eat a lot of ice cream. So this is a positive correlation, and you can say that. And the same way on the other side, if weather is cold, people won't buy much of ice cream. So this is a positive correlation between weather and how much of ice cream is being bought. So why we are doing this, and similarly, as Shiva suggested, there is a negative correlation and there is a zero correlation, which means these two are not related. Now, correlation does not necessarily means they are actually related, but because we are selecting factors in such a way that we think that they are related, if we see some good correlation, we know that they are related. Like when I say that weather is going up and down, and accordingly ice cream sales goes up and down, we know that whether people buy due to weather. So this is the idea. So in our case, we are saying, okay, look, if there is a difference, if there is a specific aspect about the selling price, if that is influencing the sales, then it should be correlated. And we see that when we run the correlation coefficient. Now you can read about what is a correlation coefficient, what type of correlation coefficient is used, all that is different. But fundamentally the idea is that it tells you whether, in our case, ice cream sales is the Y, that is the number of sales items being sold, and temperature is any of those different other features that. So what we are trying to do is each one of them we are seeing if they are correlated. if they are correlated, then we say, oh, look, this is influencing somehow, so you want to know how. Yeah.
Oh, the diagonal. It's like basically when the correlation between two, it's like this. You can take correlation between any number of variables. Okay, let's say you have correlation between 5 variables. This will be a 5 by 5 matrix, right? So the diagonal, whichever element you take, element ij is the correlation between variable I and variable j. So in this case, if you take the diagonal elements, the correlation between an element with respect to itself is always going to be 1 because it's perfectly correlated with itself.
No, that's why correlation matrix is always symmetric.
We can actually barely hear you, Harish. I don't know if you need to bring that microphone close to you.
Yeah, that's why I'm trying to hear.
Staying at the 0, that means
Right.
And if we change this exercise, that is 0.3, so is that error will increase or decrease?
It's like this. It's like this. The main thing is training. You want to give enough thing for training. So basically, it's like this. If you have very little data, then it is best that you give more for training. Training, the more samples you have for training, the better your model will be. But you need to test it as well. Because unless we have a sizable test data, you won't be able to know whether your model is good enough or not. So you have to sort of compromise. Here in this case, we have decent amount of data. We have like around 500,000 data points. So therefore 0.3 is okay. It is usually better to take around a larger proportion of training data. If you have like billions and billions, then you can even take around 0.5 because you have enough data. So that's how it is. Actually, come to think of it, if you just scroll up and you see there is a coef this thing. I think we plotted out the coef thing. Krishnan, are you there?
Yeah, just a second.
Oh, yeah, okay. If you just scroll up, there is the coef vector that we were just looking at. See, where is coef?
Coef underscore x, right?
Yes. See, if you look at the coef underscore x, this coef underscore x, you see that these are the coefficient corresponding to the variables. So if you look, I think snap CA is the second variable. And if you look at the coefficient, it is the most negligible after that last one there. I don't know what that is. There is 2, minus 0051 and 005. So this shows that when something is actually not at all correlated to the output, the coefficient will be negligible. Okay. Yeah, so I guess this is it.
Yeah, that's it.
Yeah, so I guess this is also the end of the series. So we shall see separately.
Yeah, and then we'll continue in some other way.
Yeah, we will continue separately. I mean, the idea is to continue making content. It is just that the content needs to be more relevant and also something that is also, you could say that it's more useful not only just for us, but also for those who view. So it has to have more novelty. this is just becoming practice sessions, which is not really helpful to us. For somebody who is just starting with data science, and we've done enough practice, so it's like not really much help if we keep doing this on a perennial basis. So I think, yeah, so the end of the series, and we shall meet separately. Let's hope we take up a good problem.
Perhaps we will keep the same timing. What do you think?
I think if it is for us, we can even have separate kind of goal settings. So
yeah, no, but let's keep, because for me it's also convenient that Thursday evening 6 o'clock. This is there. So, and if you want to increase, I mean, if you want to meet more often, we can cancel this if we have met, Wednesday evening for 2 hours or whatever.
Uh-huh.
But what do you think? Because I feel this is a lot more comfortable, because if nothing, we can at least come here, half an hour, we can talk about what we are trying to do, what we want to do. And
that's okay.
Every week we have some mechanism to connect, and then so that we at least keep in touch. Of course, it's not necessary that must meet. It's not necessary that we have to show something, etc. But it might be an interesting.
Yep, that'll do. That'll do.
I'm going to, with this idea, I'm going to try seeing if we can hunt for some benchmarks, interesting benchmarks maybe, so that we can discuss about it the next time we meet.
Okay, that'll do. I mean, problem searching will take like a month or so. So I would say that we wouldn't jump onto a problem. Even to actually fully understand a problem will take a month.
Yeah.
Then we can start modeling, and then we can start searching. So this is like, I'm looking at like a 4 to 6 month project.
Okay, sure. Yeah.
Okay, so Harish, we are all connected on LinkedIn, so we can start something and then maybe we can reconnect wherever.
Okay, perfect.
Okay then, goodbye.
See you.
See you.